Welcome back, students, in the second part of pressure. Here we are going to discuss about Pascal's law and Archimedes principle. Let's start. Blaise Pascal, who is well-known mathematician, physicist and philosopher, his work in the field of fluid pressure is very important. One of his work we are going to understand, which is also known as Pascal's law. Pascal's law states that the pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions throughout the liquid. Let's understand this principle with a small animated video. Here you can see that when the piston bin pushed down, the water is pumped out evenly through all the holes. This is because the pressure applied through the piston is distributed evenly in all the directions. Now, let's understand this principle with one more example. Here you can see a glass flask with connected tubes in which the water level is same all around, as liquid seeks its own level. When the piston been pushed down, then in all the tubes the level of water rises equally. This shows that in all the tubes water is receiving equal amount of pressure. This is only Pascal's law. When pressure is applied at one point in a confined fluid, it is transmitted equally in all directions. Welcome back, students. After the video, now I hope that you had understood the Pascal's law. Now let's understand its applications. Pascal's law can be used to make different kind of instruments like the hydraulic lifts, hydraulic jacks, hydraulic brakes and hydraulic pumps. Now let's understand Archimedes Principle, another very important law related to fluid pressure. According to Archimedes Principle, when an object is immersed in a liquid, it has an upward buoyant force equal to the weight of the liquid displaced by the object. Let's understand this principle with a small animated video.
Say you have a beaker filled with water and you put your index finger inside it. You'll observe that the water level rises slightly. You put in 2 fingers, the water level rises a bit more. And now when you put in your hand up to the wrist level, you'll see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. When he got in, he realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes in. Keep this thought in mind. We'll come back to it soon. In our previous videos, we've seen that when an object is placed in or on the fluid exerts a buoyant force on it which acts upwards. The Archimedes principle goes just one step further in saying that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. We can take a simple example to understand this. Take a 5 kg solid object and suspend it by a spring balance. The balance will read 5 kilograms. Let this be the first case. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is. And we keep a small container under the opening. Now slowly lower the solid object into the water and you'll see that the reading will be lower number as compared to the previous case. Why is that? It's because of the buoyant force acting on the object. You'd have also noticed that some water was displaced. Now in this context, we can say that the weight of this displaced water is equal to the magnitude of the buoyant force acting on the object. That's the Archimedes principle. When an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. Where is this principle applied? Can you think of examples? How do you think large steel ships float? It's simple. If the weight of water displaced by the vessel below the keel is equivalent to the vessel's weight, then everything above the keel will remain afloat. That's because the water too applies an upward buoyant force on the ship, which is same as the weight of the water displaced by it.